Hello and welcome to another one of D's ADD videos. Today we're going to look at a P over Q problem in which the leading coefficient A is not a 1. So what you do is you first look at this problem and you notice you should see that there's an X common to everybody. So you factor out an X. And I'm just using had over factor to figure out what's left. If you don't understand what I just did, make sure you go to the video for factoring out the greatest common term and practice that concept, because that's something you should be able to do pretty easily by now. So let's look at what we have left. Here is my constant. That's where my P comes from. This is where my Q comes from. So I've taken the liberty of writing them down already. So if I take 54, all the factors of 54 are listed in my P's. Okay? And all the factors of 2 are my Q's. And then P over Q, when I do P over 1, I get all the terms from P. But then when I do them over 2, I get a few new terms. Okay? And any of the 2 over 2, for instance, 6 over 2, 54 over 2, these are all accounted for in the P, so I don't have to repeat them. All right? So then after that, what you do is you can either use the factor theorem and start plugging in your stuff just to make sure it's a root, or you can do synthetic division until you get 0 as a remainder. Okay? So I prefer the synthetic division method. Again, let me just show it to you in action. Here we have, oops, wrong color. Coefficients of your polynomial. And I'm going to try 1, for instance. Okay? If I do 1, bring down the 2. 2 times 1 is 2. You add these 2, you get a negative 1. You add these 2. You can already see that that's not going to add up to a 0. Right? So what that tells you is x equals 1 is not a root. And x minus 1 is not a factor. Alright? So then what you do is you pull out your eraser, your handy dandy eraser. I guess I should have only erased the bottom part. And if you weren't thinking like me and you erase the coefficients, then rewrite your coefficients. And I'm going to use the problem solution to figure out that 3 might work. And you're going to get a negative 6 there. Here we get a, oops, positive 18. I almost wrote a 9, negative, I don't know, it is negative 9. This is what happens when you wake up early and make videos. You get tired. Negative 3 times negative 9 is a positive 27. And then here, ooh, that should be a negative 45. Glad I caught that one. I was about to panic. Here we're going to have a difference of, let's see, 18 it looks like. And 45 is the larger number, so it's negative 18. And then when you multiply 3 times 18, sure enough, you get a 54. So that becomes a 0 there. Okay. So this was a cubic function, so now this is a quadratic function, meaning I can put in an x squared there, an x there, and then you should be able to factor this. And granted, this is not your everyday factoring problem, so I'm going to use a little factoring by grouping. Refresh your memory on that. You take 2 times, you could do synthetic division again. Those of you that want to continue doing synthetic division, all you would need to do is you would try another number. Negative 6 would work if you were doing it, or I think negative 3/2 might work. But I'm going to prefer doing this method because I feel more comfortable with this method and I don't want to keep guessing all the time. This is a fail-safe method for me. So I do negative 36 off to the side, factors of negative 36 that add up to negative 9. So I think we got 3 times 12, right? That should do the job, and the 12 should be negative. So once we figure that out, you break the middle term up into those two terms. It doesn't matter which one comes first. I usually put the positive term here on the second expression, that way I don't have to worry about factoring out negatives. And when I factor out the common 2x, I'm going to get an x minus 6. And if I factor out the common 3 here, I get an x minus 6. And if I factor out that x minus 6, I get a 2x plus 3. And then if I include this x minus 3 and the x from before, this now is fully factored. I want you to note something. Even though this is a minus 3 here, whenever it comes into the factor, it becomes a plus 3. Reason being, when I have x equals a negative 3, I add 3 to both sides, and that's what the factor looks like. Okay? If I wanted all the roots for that equation, I just set all of those individually equal to 0, and you'd get x equals 0, x minus 6 equals 0, and x equals 6. And you would continue, 2x plus 3 equals 0, x equals negative 3 halves, and x equals negative 3. We got already. So you would have 0, negative 3, negative 3 halves, 6. That's it. Those would be your zeros if you were asked for, oops, sorry about that. If you were asked for your roots. All right, so practice, practice, practice. These are pretty tedious. You can make little mistakes here and there. And the best way to overcome the fear and anxiety you might have right now is just to do 20, 30 of them until you can do it and no longer mess it up. All right? I hope I've cleared up any confusion that you might have. Thank you and have a nice day.